Okay, so this is another example of in assembly doing indirect addressing. And let me just give you a short synopsis of it, and then we'll get down to the actual details. So basically what we want to do is we want to implement the C function strlen, right? And the strlen function, basically what it does is it gets a pointer pointing to the beginning address of a string of characters, and then it tells you how long the string of characters is, and it does so by looking for the 0 character at the end of the string. And when I say 0, I don't mean the numeric value 0. So if you have a string like apple, right, in the memory you're going to store the ASCII code of A, the ASCII code of P, the ASCII code of PLE, followed by 0, and not the ASCII code of the numeric 0. So the numeric 0, I think the ASCII code in decimal is 33, but this is 0. You actually store 0 in memory. And an example is shown here in which we have the string apple. And by the way, the way that I see this is file registers. I think you have seen that before. So I say debug, no, sorry, window, pick memory views, file registers, and then you can hit this button, this arrow, and say, I want to go to address 800, or just scroll down to address 800. And don't try this at home. I mean, if you do this, this location will be empty in your case. I have ran this program, and that the program copied the values of Apple into this memory location. I just want to show you how to read the memory location. So I'm reading. So let me first show you. So this says Apple followed by a dot. So it doesn't show characters that are not visible. So the characters that are visible are, A, B, C, D through Z, plus the, operators and stuff like, like parentheses and stuff like that. Anything before, anything with ASCII less than 32 is not going to be shown. It's going to show it as dot, and so on. So Apple that you have here is going to show here. So we have 7061, and this is at address 800, and then we have 6C70, which is at address 802. Now remember, this is the least significant bit, so this 61 is the hex code for A, 70 is the hex code for P, and then here the least significant bit is here, the least significant byte is here, so 70, the second P, and then 6C, which is the L, 65, which is E, and 00 is what you have for the Apple. Now remember that this is true in C as well. When you look at memory, a string could be written many times, right? So maybe before writing Apple to this location in memory, you wrote something else. And when you say copy, so if for example you use the strcpy string copy instruction in the C language, then basically what it does is it copies Apple, puts a 0 there. It doesn't care about the rest of the memory, right? So this array that it stores, maybe 20 characters. It has room for 20 characters. It could have junk after that apple thing. So here you can see that it says apple and then 0, orange, 0, pear, etc. Right? So you don't care about the rest of it. You start from the beginning that you have the apple, and then as soon as you hit 0, then you will stop. That's basically how you would operate and how you would determine the string length. Now before I start talking about implementing the string length, let me just remind you what we did in lecture. If you remember, we said let's copy 10 elements of array A into array B, and then array A is defined as dot space. By the way, this is useful too. So the same way that you would have the pound defined in the C language, you could have similar things here. So you could say dot EQU num elements, comma, and a value 10, right? So now num elements is going to be constant, and before even trying to compile the code, it's going to replace every instance of num elements with the literal 10, and then it's going to compile, right? pretty much the same way as the define in the C language works. And then you can use expressions like 2 times num elements. Now, no assembly instructions are going to be run calculating this 2 times num elements. This is all the compiler. Before it even compiles the code, it knows this is a constant, so it knows how to do 2 times 10. So it's going to put 20 here before even attempting to compile. Okay, so your A array, your array A and array B are each 20 bytes of text, and then essentially what we did in class was move W10++ into W11++, and if W10 and W11 is started as at array A, array B, then essentially it's going to increment to the next address and copy the values from array A to array B. And here, of course, we have the decrement W-reg branch not zero loop. This part is the loop construct that we have that results in this thing happening 10 times. Okay, so that was the first example that we did. Now, the second example that we did was basically add a bunch of words into another word. So, in other words, you're calculating sigma AI, I going from 1 to 10, and put it in another word and ignoring any carry that you might have. So basically what happens is that here you don't have 2 arrays, just 1 array, and W12 is the accumulator. You clear it at the beginning, and then you add your existing value of the accumulator, which would be the elements from 1 to I minus 1 plus element I, and then put it back into W12, and then you have your loop construct and you're done. And if you remember, after this we said do the same thing, except that here your elements are bytes. And when you do that, then basically your add becomes add.b, and because the .b gives you the context being a byte instruction, then essentially what happens is that the lower 8 bits of W12 and the lower 8 bits of the value in the memory are going to be involved in the computation, and W10++ is not going to advance W10 by 2, which is word, it's going to advance only by 1, which is the byte oriented thing, right? And we want to do exactly the same thing with string length, because you're dealing with byte oriented things, right? So if I want to go ahead and implement a string length, essentially what I'll have is the memory view is going to be something like this, and I have the address 800. Now, instead of showing it as word addresses, let's make life easier for ourselves and show it as byte addresses. Okay, and I have 802, 803, and so on, and I can show the A here, and what I mean by it is the ASCII code for A, but it's easier for us to look at it like this, and then I have APP, and then L, and then E, and then 0. Okay? Alright. Now, what I want to do is have a loop, right? So, I mean, obviously, we need to have a loop to go over A, and then P, and then P, and then L and E, right? We also need a counter. We need a counter that says at the beginning, I'm going to be 1 for A, and then as soon as I scan the next letter and it's not 0, I'm going to increment it. So basically my loop is going to be, my code is going to be like this. So let me write the high level description of it. I'm going to say my count, let's just put W12, is 0. And then what I do is I would say let's say W5 is 800, the beginning address. And then I have a loop. That says increment W5, go to the next word, and check to see if W5 is 0. If it is, then do a branch. If it isn't, do a branch not 0 to the loop. Otherwise, you're at the end of the loop and your W5, you also want to increment W12. So you would do plus plus W12, which is the string length, right? And then W5 is the pointer to your string. Okay, so essentially what you expect, and by the way, this is not the final version, right? I mean, I'm intentionally just babbling along and writing what comes to my mind. This is not the most efficient way of implementing it, but I'll get to that in a minute. But let's first take a look at the behavior of the program. Now, if I do this check as a .b, and maybe I want to put a .b here too, just to remember that when I translate this to assembly, I use the byte version of it. So essentially what happens is that W5 is going to point to this 800 thing, and then W12 is going to be 0. Now, I'm going to increment W12 to 1, and I'm going to increment my W5 to point to the next word, right? And if this next letter, sorry, not next word, next letter. If this letter is 0, then terminate the loop. Otherwise, go back up here, and I increment W12. Now it becomes 3. Sorry, it becomes 2. And then W5 is going to point to here. So when W5 was pointing to here, W12 was 0. Here W12 would be 1. Here it would be 2. Then next iteration, W5 point here 3. W5 pointing to here, and my count would be 4. Then when I go back up there, W12 is going to be incremented, which is 5. W5 is going to increment to here, and then if I check this to be 0, then I do branch not 0. I go out of there, then basically W12 is going to give me the string length. Now, it's quite likely that if you write this code, and maybe I didn't emulate it, maybe I didn't simulate it carefully, sometimes what happens is that at the end, your string length is going to come out as 4. Not 5. And then you would say, oh, how do I fix that problem? And then you go here and change it to 1. So instead of 0, you would say start with 1, and that's going to fix the problem. I don't think that's the case here, so I'm going to just put it back to 0. Now, there's one problem with this code that I'll get to in a minute, but let's take a look and see, how we would translate this into assembly. So I'm going to skip these, trivial instructions like, W12 equals 0 and so on. You can just do clear W12 and then move ASTR into W5. Let's go ahead and do the loop. So if I have the loop, all right, I want to increment W12. Well, I can simply do increment WReg 12, and that's going to increment the value that is in W12. Now, if I want to increment W5, I can use simply increment, right? I can simply use increment and say increment the WReg5, and that would be okay because I wanted to increment by 1 and not by 2. If I wanted by 2, I could use the instruction inc2 WReg5. But I can potentially combine these two instructions, right? What I can do is I can check to see if W5 plus plus, or in this case I want to do plus plus W5 to be 0, right? So my operand here is going to be plus plus W5, right? And the reason I have plus plus before it is because I first wanted to advance like this and then do the check, right? Now, how do I check to see if a value is 0 or not? Well, I need to go back and check the manual, but I guess one way that you can do it is initially you could set W0 to 0 and then do a compare, right? I mean, that's one way of doing it. I could just say this and W0 and put the results back in W0, and that will do the trick. And then I can, oh, And by the way, this has to be .b. Now you have to check the manual to make sure that such an instruction does exist. If it doesn't, then maybe do subtract, right? Oh, and by the way, CP doesn't have a destination. CP is the point of CP is exactly that you do subtraction, but you don't hold the result. You don't keep the result anywhere. And then I have my branch not zero into loop. And and basically that's going to take care of it. Now the only problem that this has is, what if my string is 0? And it does happen, right? In the C language you would have this notation with no spaces between these double quotes, and this would be 0. And when it is 0, then basically means that you have a 0 here, and that should return a string length of 0. But that doesn't happen here, right? Because if it is 0 at the right at the beginning, I'm going to increment W12 and immediately say that my string length is 1. And I'm going to increment W5 and go to P. So I'm just going to miss this 0 and skip it, not detect that this is a string length of 0. And that's absolutely fine. This is what happens in real life when you code things. The very first version might not work, so you try to come up with patches. I mean, the patch could be either a band-aid patch. I could, right before the loop, I could check, I could do the compare of W15 without any pluses, and if that's the case, then just go to after the loop. That would be one solution. Another solution is to go back and think about the loop itself and what you want to do. And that's the code that I'm going to show you next. The code that I'm going to show you is going to basically have the checking of the 0 value right at the beginning of the code of the loop, and then it's going to go ahead and increment things and so on. So let's go and take a look at the string length that I have. And for now, just there are bells and whistles like the technique that we used in discussion 3. I have some constant values in my program memory that I'm going to load into data memory and then do this stuff. But essentially what I'm doing is that after I copy from program memory to data memory, I put the pointer of the string length into W1, and then I call strlen. strlen is a subroutine, and it's going to put the string length back in W2 and return the result. Okay, so right at the beginning of the loop, I'm testing. I'm saying cp0.b. So cp0 is going to compare to 0. You don't have to load W0 with 0 and do compare against W0. So it's first going to compare W1, the content of W1, and that would be your A in the example that I showed you. And if it's not 0, it's going to not branch. And it's going to increment, branch back to test Z. Okay, so by testing W1 and then incrementing to the next, you can catch the cases in which your string is empty and your W2 is clear, it's 0. So if right at the beginning the first byte is 0, you're going to do a branch 0 end string length and pop W1 return with the value of 0 into W2. If it's not 0, then you're going to increment W-rich2 for each character that you see, go back up there and be done then. I can simulate the code next and show you how it actually works. Let me just pause. All right. Now, in terms of simulating the code, let me just go over the whole code so that you can see, what the whole thing is. And I'm going to post this on Moodle too. So here I'm using the trick that we used in discussion 3. So I have some locations in data memory, ASTR, BSTR, and of course, here I don't need BSTR, just one A string is enough. And I define a stack because I defined strlen as a subroutine. And this is the strlen subroutine that we went over. And then I'm using the same trick as discussion 3. So you have operation, operator 1 and operator 2, sorry, operand 1, operand 2. And I've used two different ways of defining a string character. You can use the dot byte thing. So if you use dot byte, then basically these two are going to combine into one word, the next are going to be combined in another word, and so on. So you can either do byte, which is, spell out Apple character by character, enclosed by single quotes, and note here I put a 0. And of course, I mean, I could put numbers here, right? I mean, in terms of E, I could just put the ASCII code of E, and that would work well. Or you can just say dot ASCII. So this is, operand 2, and this is the second example string that I can use, and this is ASCII orange. And note that I put the /0. So when inside the quotation, and this is just similar to C. In the C language, if you say /0, then you're going to add the ASCII 0 to it. And then I have pair, and then I have this up4, which is byte 0. So this is a 0 length string. This is an empty string. Okay, and then so what I'll do is I'll basically ask the compiler to give me the addresses of any one of these two guys, and setting up the stack, and then this is the PSV page. I clear it because I'm right at the beginning of the program memory, and then I say, give me operand 1, put it in W4. And if you remember, just a reminder that this PSV offset is going to set the most significant bit of the address to 1, so that when you use W8, when you use brackets W8, it knows that you're actually referring to program memory and not data memory. And then what I do here is I move ASDR into W9, and in the main loop I just say repeat 10 times. So this is an assembly instruction. If we haven't covered it, look up the manual. Basically what it does is it says repeat the next instruction literal times, and this is 10 times. So for 10 times I'm going to move W8 into W9. And note that here I really didn't have to do it. I mean, I could have just read directly. So basically what this does is it goes over 10 characters in W8, and in this case I put W8 to be up 1. So it's going to go to up 1, and then starting here it's going to copy 10 characters. So that would be Apple followed by a little bit of orange, right? And here I don't care if I'm copying Apple and part of orange, because I have that 0 terminating a string here, so it should be okay. It's just the way that I said, at most I have 10. And this is really harmless as long as I don't go beyond a space of 40, right? Because this part of the memory is dedicated to me, and I can just go ahead and copy 40 bytes here. I only did 10. I only did 10, so I should be okay. Sorry, I actually did 20 because this move is a word. So yes, I'm copying the whole 20 bytes from program memory to data memory. But again, I could have not done this and directly worked with W8 as a parameter to be passed on the string length. Now, this is the core. This is the core of what main is doing. So after I do the copying from program memory to data memory, now I'm saying move the address of ASDR into W1. And remember, W1 is the parameter that strlen expects to receive. So that's going to be the beginning of the string. And the strlen is going to give me the length of the string into W2. So let's go ahead and run it once. And I have a breakpoint here. Hello. All right. And you can see that in the memory at address 800. So this is not the program memory. This is the data memory that I have. And in the data memory, after the copying is done, I have Apple, orange, pear, and 0, right? So the 20 bytes that were copied are here, and now I do rcall. Let's take a look at our registers. So my wreg1 is 800. That's what I did. I put ASTR into W1, and then wreg2 is 0. And if I just let me So if I do this step over, then you can see that it shows me 5, and 5 is correct, right? Apple has 5 characters. Now I can go ahead and do orange, and simply if I want to do orange, I would just put the up 2 here. Instead of up 1, I can do up 2. Now let's take a look at the up 4. So up 4 is the case that you have the empty string, right? So then I can just say compile again and run. And note what happens at address 800, right? 800 has a value of 0, and then these guys are just copies of whatever junk that you had after that, right? So this is stuff. Let's see what it is. So up 4 is byte 0, so 1 byte of it is going to be this 0 thing. But after that, I'm going to have the opcode of BCLR and move and so on and so forth. So this is what you get. So this is the 0745828F. These are, and if you, I haven't looked at it, I haven't checked it, but I bet if you check, you are going to find that these are indeed the opcodes of these. Because what the beginning of the program does is essentially says set the beginning address up 4 into W8, and then do 20 bytes of copying from program memory to data memory. So this doesn't care that actually the things that you're copying are all going to be the string characters, right? It's just copying 20 bytes starting from the address that you give to it. And then when you want to execute strlen, let's go inside strlen. So instead of saying skip over, let's say step into. And by the way, one other thing that I did here is I pushed W1. Remember, W1 has the address pointing to the beginning of the string, right? So in strlen, I copied this to stack. I made a copy of W1 because here I'm incrementing W1 and I'm just advancing through character by character through the string. But at the end, I'm going to pop W1. Why do I do that? I really don't have to, but I guess it would be nice if I could just set W1 once and then call a couple of functions. Maybe I want to find, how many characters are in there, how many capital letters are there, or maybe I want to copy from W1 to another string pointed to by W10. So this allows me not to reload W1 with ASDR every time. And, essentially that's going to be a trick that I can play to keep the parameter that I pass to this strlen not change. Okay, so let's take a look. So we do W1, push W1, clear W2, so you can see W2 is 0, and then I'm comparing as a byte W1 plus plus. Let's take a look. So W1 is 800, so I expect 800 to become 801, which it does, 801. So it didn't come 802. If I delete this .b, then it would be a word context, and W1 plus plus would result in W1 becoming 802. But here it's .byte, so it's going to advance to the next byte and not the next word. And because I had the 0, and see the 0 flag, it did become highlighted here. It's capital Z. So branch Z is going to take effect, and I'm going to end this str. So I didn't touch W2 after clearing it, right? So I clear it. I assume that my string is going to be an empty string, and that happened to be the case. If I had any non-zero characters, then W2 would have increased here, and I would have incremented the length of the string. One last thing that I want to check is whether or not I can just cheat and, without copying things into ASDR, just go ahead and do the same thing in program memory. So I can set this as a comment and then change this to W1. I don't know what happens. I haven't tested this myself. So let's skip this copying and skip this. So basically what I did here is I said put that program memory into W1 and then call strlen. And let's go ahead and do operand 1. So this is our apple. So let's go ahead and do this. Alright, so wreg is 0. And note here, wreg1 is 8 2A8, right? So this is exactly the program address, 2A8. And if you doubt, then I can just go to Window, pick Memory Views, Program Memory. So I should be able to skip this 8. 2A8 should be the address in which we have that set of values. So up 1, see, up 1 has 70, 61, 60, 70. So this is the apple, right? A is 61, P is 70, P is 70, L is 6C, right? So my address starting, pointing to Apple is 2A8, and see what it did. So this PSV offset operator from the compiler just added the most significant bit was set to 1 of the address. So the address then became 8 to A8. And now let's just execute that, and it's just going ahead and doing the computations one by one, counting your W-reg. And return, and you can see that W2 is set to 5, which is Apple. So we could have directly worked with program memory because we are just reading, right? I mean, we are not writing, we are not modifying Apple. But if my problem statement, for example, was, and this probably is going to be a good homework example, get a string of characters and it convert all the lowercase letters to uppercase letters, right? Then in that case, you're going to read Apple as lowercase, and you want to change A to the uppercase A, P to uppercase P, and so on. And if you're doing the program memory, then you probably don't want to do that. You want to avoid risking, writing onto program memory. So you would first copy things into data memory and then do all your modifications on your data memory. Okay, that's it. I better stop here.